So what I was saying is that in the attribution modeling, you can also apply the survival analysis. You can apply survival analysis because what is there, the duration is there, what the person is going to click, when the person is going to click. You can always predict from the past digital behavior of the person. Do you have any question as of now? Ask me. Do you have any questions? Any questions as of now? Am I audible to you, all of you?
Yes, sir. Could you explain what is attribution modeling and how is it used?
Okay, sure. Your name, please.
Sir, Varnika.
Yeah, sure. So I was discussing that in the context of lateral thinking. Lateral thinking means that once you have learned a particular technique, how you can take that learning to the other or different scenarios. That was the context. So I was discussing with you that survival analysis originated from healthcare analytics. And then you can take it to the context of churn analytics. For example, customer is going to churn or not going to churn. Customer is no. Uh, if they're going to churn, at what probability and in which month, at what point of time. Now, in that same context, in the same breath, rather, I would say, I was saying that survival analysis can also be applied in the realm of digital analytics. And then I started the concept of conversion analytics. What is conversion analytics? Whether the person has been converted, that means purchased or not purchased. So from that perspective, I was discussing, say for example, before a person gets converted, the person touches multiple websites like social media prompts a purchase to come to the company's website. So multiple touch points are there. So what is the impact of each of these touch points on the conversion? I was discussing that part. So how is survival analysis related there? It is related because if you know that what is the duration a person takes for conversion, and again for not conversion, converted, not converted is one column, the duration for the person to become converted is another column, and you have got all the independent variables like the views and clicks as the different factors. So again, you can apply this technique, survival analysis, into the digital analytics or attribution modeling or multi-touch attribution modeling or conversion analytics, whatever the name you say. Am I clear with what I'm saying?
Yes, sir.
Perfect. Perfect. Okay, so this was again I discussed the LSTM part, deep learning part when I discussed this, and finally I discussed about the promotion response modeling, which can be done through propensity score, and finally the customer dashboard should be prepared. That I mentioned that in any business, it's very important to create a presentable dashboard of visualization, and in that context, I discussed with you that what's the best software, what's the different tools and techniques for the data visualization or dashboarding or storytelling, and I discussed about the Tableau part. So with that, let me stop this presentation. After that, I discussed with you the segmentation. Yeah, this one, I guess. This was more of a kind of platform, and I also discussed with you the segmentation of a kind of real life scenario. And then I discussed with you the recommendation engine. In my last class, I discussed with you content-based recommendation, collaborative filtering. Any questions on any of these techniques? Because if I just name it, the slides are already with you. So any questions on segmentation techniques or the target marketing techniques like propensity modeling, uplift modeling? or the segmentation, or how I would discuss that how the decision tree was applied on the top of cluster analysis results, how a couple of techniques can be combined. Any thoughts, any questions? Feel free to ask me before I move to the next topic for the day, sales forecasting.
So one thing I need to ask.
Please.
So during, if we having this examination, what kind of questions we will be getting? I mean, how will be the question will be there?
See, if I take the exam or wherever I take the exam, I don't know about what about the other things. So with the 40 marks, I shall evaluate you. And I shall give you, different, thought-provoking questions. Like I shall tell you that what kind of solution framework you can design in a given the kind of question I asked you. For the Lenovo, for instance, I can ask you that. I can ask you like, in a particular sector, not even a company. Say, for example, you have to develop a churn analytics problem for a telecom company. Okay, then how should you approach that problem? What kind of develop complete end-to-end proposal other than the cost part? Like how should you approach the technical part, solution framework, and then the what kind of algorithms, what kind of approaches, what kind of algorithms. Telecom, you have to understand also, do kind of little bit of study about the telecom industry's challenges. I shall give this kind of questions, and I shall share in my next class what exactly you have to do for this 40 marks of evaluation. Uh, Besides that, I shall give you different other scenarios, and then I can case that yes, can you do some kind of lateral thinking, like you have learned multiple classification algorithms. So can you apply those kind of classification algorithms in different scenarios? So that's the kind of that's the kind of tests or exams you are supposed to face, not only in your organization, not only your college, but also in the organization where you are going to work.
Got it, sir. Thank you.
Okay. Okay. Any other questions on the retention analytics piece and the customer acquisition piece? I don't mind to clarify further if you have any question. Else I shall start with sales forecasting. Any questions, guys? Any questions on whatever has been taught till now? Entire business conservation and retention analytics, the first piece, and customer acquisition, the second piece, which includes segmentation, targeting, and recommendation engine. Okay, if there are no questions, let's start with the sales forecasting part. So what is sales forecasting benefits that you all know, right? What I'm going to do today is that three things I'm going to do in the sales forecasting piece. Number one is the modeling architecture. I shall walk you through the multiple algorithms that have been commonly used. I shall walk you through a use case that I have accomplished for a client, the way I have shown you for the segmentation. I've done it for a bank in Southeast Asia. In the same way, I shall show you how I have done it in Mexico. I did it in last year only. I was in Mexico and accomplished it. And that's the use case. And the third thing I'm going to show you over a real life data set, how you can do it. And that's the easiest one, I guess. So I have considered, four techniques that we are going to use for this class to walk you through the different approaches for Shapley value regression, for sales forecasting. The first one is Shapley value regression. Typically, this has been used when you have got multicollinearity. That means that there is a lot of correlation among the different independent variables, and so that's the multicollinearity problem. ARIMA is the most commonly been used for the seasonality trend. Shall also walk you through to a real life data how you can use this kind of ARIMA tools. The most traditional, you would say, technique, and still an excellent technique that gives superb results. In the statistics part, extreme gradient boosting, the decision tree, or the random forest, these are all that typical classification problems or the prediction problems, classification problems, but how I can transfer that kind of classification problems to a kind of prediction problem. I shall also walk you through that part. This long short-term memory I already discussed with you in the first class regarding attention analytics. Nevertheless, I shall still throw some more light at how that can be used. Okay. So with that, let us understand the Shapley value regression typically been used to figure out a kind of relative importance. Intentionally, I have given an example of digital analytics where there are multiple paths, right, for the entire transaction. So that if there are total transactions for the three paths like ACM, display, search engine mechanism, display, and search engine optimization, it can be any path for that matter. These are only the examples, right, are 500. And these are the kind of individual ACM 100, displays 125, SEO 50. Then what is the kind of relative importance? That's what I was discussing in the when I was discussing attribution modeling. How much will you attribute to the different path for the conversion? So ACM plus display gives 270, SEO plus ACM 375, SEO plus display 350, ACM display SEO 500. So what is the importance of each of these? Shapley value regression helps us to identify and figure out that part. So how does it happen? So we know we have a few statistics like ACM display SEO 100, 125, 50. We have just plotted that thing. ACM 100, display 125, SEO 50, right? Very easy. And then we know that, what do you know? SEO plus display is 270. Sorry, ACM plus display is 270. Yeah. So we have mentioned that thing only. So if I have to just, subtract the displays importance. So 270 minus 100, this is the 100 part, right? We're getting 170. And then 500 minus 270, why 500? Is the 500, okay? Where we have got both, all the three, not both, all the ACM, display, and SEO. If you just subtract ACM and display from ACM, display, SEO, so that's what you are getting for SEO. Okay. Simple logic. Now ACM is 100, SEO is how much? 375 minus 100. What is 375? If you look here, like SEO plus ACM is 375. And this is your 100 base. Like if you just subtract from 375 to 100, that's another perspective. You are getting 275. So in that way, you have calculated the exact importance, or that's what, not exact, it's the relative is a better word here, relative importance of it. But the regression gives you the exact, but Shapley value gives you a kind of relative importance. So display, if you look here, 500 minus 375. So you have got the 500 and here is the 375. ACM plus display SEO is 500, ACM plus display is 270. So for the SEO is 500 minus 275. Yeah, you're getting that 125. So that's how it has been calculated. Now, if I have to calculate the marginal contribution of ACM, what I should do? So 1/6 of all the 6 parts, 1/6 of ACM I have found here 100, 100, 145 I got here, 150 I got here, 150 I got here, and this is 325. So all the ACMs have taken and multiplied by 1/6. Similarly for display. So that's why this color coded, color coded differently. All the SCMs have been, gray, display black, and this SCUs are sky blue. So display again 175, 125, 125, 125, 300, 125. And then the SEO part is again is 230, 275, 230, 225, 50, 50. And finally the attribution percentage. So CM is this is the one, is the SCM's contribution 161.66 divided by all the other 3 contributions, 161 plus 161 plus 176. That's the marginal contribution. Similarly, display 161 divided by all the remaining 3. Similarly for the SEO, 176.66 divided by all the remaining 3. So that's how you can calculate the Shapley value. It's pretty simple, but in many of the scenarios, this proves very handy, let's say. So with that, let's come to the next one. Next one is the ARIMA technique. Again, widely been used in the industry from a very long time. ARIMA stands for, you must be knowing all these things like autoregressive integrated moving average. And what does autoregressive means? Indicates the evolving variable of interest regressed on its own lagged own lag means it's the prior value. So if there are subsequent or consequent error terms, and if you are regressing on the error terms, that is the auto regression part. And I indicates data values have been replaced with the difference between their values and the previous values. So you have got, and there can be double differentiation also. Like if you are subtracting for the first one with the previous one, then y minus t1, you are given the y hat. So that's the kind of difference you are getting. I've also mentioned D is the degree of differentiation, the number of times that have been had the past values subtracted. And T is the number of lags of the autoregressive model. Autoregression means you are actually doing it within yourself, within all the error terms you are doing the autoregression. And moving average indicates that the regression error is a linear combination of the error terms of the present and the past. So this is the present ET, and then it is YT is the Y means, of course, you know, the current dependent variable. T is the current time, and then ET minus 1, ET minus 2, ET minus Q, like that. It is a kind of regression error. It's a linear combination of all the error terms. By the way, you know what is error term, or you have a problem there? Do you know what is an error term? Because I assume that you know error term. Do you know what is an error term? Yes, no?
No, sir.
Okay. So tell me, just, you know, feel free to stop me, because while I speak, I assume. By the way, I have not perhaps asked you. Have you understood Shapley value part? Yes, no? Yes, no?
Yes, sir.
Okay, great. So error term means that whenever you write an equation, right? Equation means a regression equation. What's the equation looks like? Y equals to a plus b1 x1 plus b2 x2 plus bn xn, and where x1 to xn are all your different independent variables, whereas the beta y is a dependent variable, and beta 1, beta 2, these are all the respective coefficients. What do they signify? Impact of x1 on y. Beta 1 signifies the impact of x1 on y. Beta 2 signifies the impact of x on y. But then not the entire thing, entire variation of the y or the dependent variable are not explained by all the independent variables taken together, right? So for that purpose, there is some part which are not been explained. There's some unexplained part. That's called error. So let me give an example. For example, you are doing it the impact of sales with the price. Price is an independent variable and sales is a dependent variable. Now maybe the entire variation of the sales is not explained by price only, right? There can be some other variables also which are not captured into your equation. Your equation is very simple. Sales equals to say 5 plus 2 into price, for example. But then besides price, there are a lot of other factors which are not been captured into the equation. So that comes under the broad heading of error. That means the unexplained part. Am I clear or not clear? Am I clear or not clear?
Yes, sir.
Yes, sir. Clear.
Okay, great. Now you think of, you know, this equation, how it is being formed. Now you think of a kind of time series where you have got the y, x1, x2 for every timestamps. Like say if I take the year as a timestamp, 1991, 1992, 1993, like that. Now for every year you have got an error term. And so now you have got a series of error terms, right? So when I'm discussing this auto regression, I'm talking about this error term at the end of the equation and how that should be considered. In fact, for all the normal distribution that we check for any regression equation, which is a kind of assumption of any regression, that also we do on the error term. That's a very important concept, error term. So those who are not acquainted with this error term, do study it. It's a very, very, very critical concept in the regression parlance, error, because we do a lot of operations on this error term. Okay, so that's the ARIMA part. I shall quickly show you also how this has been done. Next comes the extreme gradient boosting for this forecasting, and typically, you know, XGBoost or any kind of boosting techniques, bagging techniques, are form of ensembles which are typically being used for the classification, right? But then I have shown you here in this picture that how or what is the way to prepare the data to convert those kind of classification problem to a timestamp problem to make the extreme gradient boosting work for you. So typically you have the data like that in a time series, like in time 1 measure is 100, in time 2 measure is 110, in timestamp 3 measure is 108. But then if you just convert that, like one is being the first one is a kind of dependent, and that is being the independent becomes the second one. That becomes the kind of prediction problem. So next your x becomes the 100, this 100, and this 110 becomes the y. So you are actually predicting the y 110 based on the y. The second one, this is what you are predicting based on the previous term. So the future you are predicting based on the past. So that kind of equation you are framing. 108 depending on 110, 115 here the fourth one is dependent on the 3. So that's how you are actually converting a kind of time series to data to a kind of predictable data, and that helps in let this kind of extreme gradient boosting to work on it. This is what I discussed already with you in the first one, that LSTM architecture is a special kind of recurrent neural network of learning the long-term dependence. Like long-term memory is also called the cell state. So what happens, I was discussing in the first class also, like what is the kind of forget gets important. So remember factor is called the forget gate, and the save factor is input gate. So not everything has to be remembered with equal importance. So certain things are very important, and LSTM has got that kind of capability with that loop, that how much importance to give to remember a particular event, and how that particular memory has to be worked while predicting a new thing. And the other more simplistic variant of the LSTM is the GRU, where you are combining the forget and include gate to an update gate. So that's how the GRU makes the life much more easier and much more effective, in the sense that the architecture gets simple. That means the computation times also gets reduced. You are getting relatively similar kind of results with a lesser amount of effort. That's the beauty of gate recurring unit. So with that, I shall give you that example that that has been accomplished in an industry. What do you want? Should I come to this example first, or do you want the hands-on session? Whatever you will say. I can do either the use case first or the hands-on.
So
I think. Tell me. Use case first. Sorry, somebody said. Am I audible to you guys? Am I audible?
Sir.
Okay. So what I can do is that, to break the monotony of this lecture method, I can show you how and you can see my screen, right?
Yes, sir.
Okay. So these are data for a kind of broadband. Subscriber for different markets are there. So there are total 85 markets are there. And we have got the data for the year. Let's come and check here the data. From January 1999, we have got the data till March 2004. So that's the kind of data we are having. Okay. So we have got data for 85 markets. All these markets have been, the subscribers in every market across 63 timestamps. Is the data clear to everyone? What we are having?
Yes, sir.
Perfect. So what we can do, we can clearly, first of all, quickly, we can check through a sequence chart. And for the sake of simplicity, I can take total number of subscribers only. And maybe the date format here, the time axis levels. Okay. Line chart, let's go with. So this is how it looks like across the timestamps, how the cells is increasing. Now I can do a simple prediction here. Let's come back here and say create models. Let's take all these variables here. Statistics is good. I take that squared as well. Plots. That's fine. I want to have a look at the predicted value. That's what you're interested. I can also show the upper control limit and lower control limit. The 95% confidence. I can give you the data is till 2004 March. That's what we have seen. So maybe, another 3 months I can predict and show to you. So it is March, April, May, June. And this is the confidence interval, 95%. So that's all is required. Predicted value, upper control limit, lower control limit. Let's see what results it throws. It's the model statistics. This is the, for every variable they have created this kind of chart for every market where it is going to head towards. And let's come back to the data set and see what has it generated. You can see here, if I can come here just and show it to you. For every market, right? So for market 1, there is the predicted value. There is the lower control limit. There is the upper control limit. 3750, 3570, 3930. That has been done for every market. Again, for the market 2, you can see here. This is the lower control limit, upper control limit. And that's been done for, look, April, May, June. This forecasting I'm doing. This was given. I gave the command to the software that April, May, June, and the 3 months. So it gave that output. Any questions? Any thoughts? Have you understood what I've done? Have you all understood the forecasting? What has been done here? Am I audible to all of you?
Yes, sir, you are.
And have you understood what I have done?
Yes, sir.
Is it true for everyone, or you have any doubt? Or do you want me to explain it once again?
So can you please repeat it?
Sure, why not? So ask me that thing. Let me close this whole thing because all things get saved. So what I have done here is that I can take any of them. Yeah, so what I was discussing with you, I've got subscribers, broadband subscribers for market 1 to market 85. For 85 markets, I have got the broadband subscribers, right? And then across a timestamp. What is the timestamp? Let's have a quick look. From Jan 1999, I have data till March 2004. Correct? That's the kind of data set. I'm interested or curious to know what is the problem statement for each of these 85 markets and the total subscribers. What is the number, forecasted number for the next 3 months? I can do it any month. I'm just showing 3 months. I can do it for 6 months also. But should be, should be a lesser period of time. So what I'm doing is that first I have shown you a kind of sequence chart and how does this subscriber base increases with time. Have a look at it, the curve. So this one I have shown to you that yes, it increases at a very fast pace, very steep curve. Is the timestamp from Jan 1999 to March 2004. That's what the increase is. And then let's move to the forecasting part. So what I have done is that I have taken all these variables that I want to forecast. This is a kind of bulk forecasting I'm doing. All the forecasting at one shot. What I want is that I want the predicted value, upper control limit, lower control limit, options, year 2004. I have given 3 months in 2004, January, February, March. I want to predict for another 3 months, March, April, June. First case after end of estimation period through a specified date. So up to June 2004, I want to predict. That's what the call is. And I'm considering all models. I could change here to exponential smoothing only, ARIMA only, but I want it, let it be all models, and that's the best thing come out. I want LCL, UCL as well. Yeah, that's all. I can have more, but not required at this stage for explaining to you. Yeah. So what I'm having here, I've got the chart observed and forecast, and this is the kind of window you can see. The window from April, May, June, 3 months in 2004. Okay, and then if you come back to the data set, first you can see here that for every market, the predicted value I'm getting, the lower control limit and upper control limit at 95% confidence I'm getting. Look here, predicted market model 2, 11510, lower control limit is 10,712, is 11,510, and the upper control limit is 12,309. So for every market, I'm getting the forecasted value and the upper control limit, lower control limit. Now that was for the past data, right? Not of that much of importance to you. But what is important for you is the future. So I have given the model up to March 2004, but the model is able to predict or forecast 2004 April, May, and June. So 12,321 is the predicted market value. LCL is or lower control limit for market 1 is 12,141, and upper control limit is 12,501. Am I clear? Making sense to you what I'm doing? Am I making sense to you guys? Yes, no, understood what I'm doing?
Yes, sir.
Great. Great. Okay. So now let me come back to a use case that I accomplished last year only in this sales forecasting in Mexico. It's for an agro industry who are into the space of fertilizer. They're a kind of multinational corporation, and I did there for the Mexico unit. So they have given me to predict the sales of 105 SKUs. Mind it, 105 SKUs. It's not 1 or 2 stock keeping units. So I'm sure you know the meaning of SKUs. From weather, sales of target crops, and market price in Mexico. From these variables, of course, this one they have not given. We had to take it by ourselves. This also we mostly took it by ourselves. And yeah, sales of target crops we got. Yeah. So training time period was given to us, was the data that were given to us is from April 2008 to March 2018. So 10 years data we got. And the forecasting time was April 2018 to December 2018. That's the kind of forecasting period, 6 months. The modeling process. First of all, we did the data cleanup like missing value imputation, outlier detection and treatment, and combine data sets in one data frame because all these data are coming from multiple bits and pieces from different sources. So they have all to be combined together. It's a very important concept. I was throwing some light in my last class, feature engineering. What is that kind of creation of new variables, variable transformation, that all comes in feature engineering. I was discussing that you cannot just take the whatever has been given to you, the raw data into your model. If you take that thing, it's kind of garbage in, garbage out. We go. So that's nobody want. That doesn't serve any purpose. So you need to really work on the features. And finally, the model development, like training, validation, and comparison. Comparison means across all the models that are applied here. Do you train all the models and then compare, validate? That's the work. So that's how the our sales volume looks like. We got it from two data sets. Again, possible. No, we found that whether these two data sets are talking in the same language or they are different. We found it they're mostly similar, other than a few cases. So this is one history data sets and this data set two. So yeah, sometimes these kind of problems appear. So it's very important to call it out to the client at the very first stage. Hey boss, you gave me two data sets and there are some dissimilarity between these two. I hope that's fine with you. Or you tell us very clearly which one we should work on. Like that. This is how the trend looks like across the 10 years. It's increased by an approximate 8.5% year on year. We found out that thing with that chart. This is from 2008, April 2008 to 2017-12, December 2017. Price has not been significant increase over the last 10 years. You can see this kind of almost flat. This was a kind of outlier. You are supposed to detect it, discussed with the client, and then we removed it. Client said, no, that was a kind of error term. Error term in the sense that kind of typo, human error in punching that number. That's the kind of, you have to remove it. You can remove it. So remove that. This is the average temperature we took for across all the Mexican states. And this is the kind of source. Very important to mention the source when you are presenting to the client. So client must know that where from you took the data. They can validate also if required. Precipitation we took. Mind it, we are not going to include just temperature or just precipitation into our model. We'll create new variables. That's very important. And then selecting and creating the creative features. So to analyze non-obvious and orthogonal drivers of sales, what kind of other drivers which might leave us an impact. So we did the feature extraction engineering, feature selection, feature scaling, and then we put it in the model. So what kind of feature we have done? So feature generator seasonality, we have figured out the trend, we figured out upward or downward shift, the normalized temperature and precipitation, isolating temperature precipitation variation from the hottest months in hot periods and hottest month in cold periods. I discussed this thing in the previous class. That's what kind of transformation you can do. The best price we figured out, the temporary price reduction we figured out. What is the impact of a kind of isolating the impact of temporary price change by distributors or retailers as promotions to drive sales? We figured out that part. And then representative feature engineering includes the log of market price. We did the log for the elasticity purpose. And this is what the we have figured out for hottest days in hot months. This is the addition of the weather we have done, like coldest days in hot months, hottest day in cold months, and coldest day in cold months. So then comes the what I discussed with you, how to do that thing. We did the same thing. The Shapley value regression. We figured out the key drivers of sales. So we explained how the total 100% has been distributed by the different kinds of variables like trends, demand effects, best price, promotions, temperature, precipitation, seasonality. And that's how the different, this 100% has been, broken down, distributed across the different factors. And that's the same way I've shown you the digital part. It operates in the same way. This is the sales decomposition to the seasonality, trained, and random. You've done that thing. And then the first model was the ARIMA, predicted sales using ARIMA forecasting. You can see is the actual is this green one and the forecasted is the yellow one. You can see here, right? This green one and this is the forecasted one. So it captures, it pretty well captures the essence of the flow or the ups and downs of this actual and the forecasted one. And these dotted lines are the UCL and the LCL that I've just shown, the min max, upper control limit and lower control limit. Yeah, you can see the same thing here, what I've done here. Mean, predicted, actual, because client wants to see how good your models are. We have done the similar kind of thing with the XGBoost, actual and the predicted. You can see here it is pretty well representing our predicted and actual. Wherever it increases, our model also increases. Wherever it decreases, our model also decreases. LSTM, we did the same thing, actual and predicted. Now, a very important part is the model comparison, right? So there are multiple ways. There are multiple ways to compare the models. So we have taken the 4 criteria to compare the models, like root mean square error, mean absolute percentage error, adjusted R-squared, and k-fold cross validation. So yeah, so everywhere we are finding that this error is the least in case of long short-term memory LSTM. So, and that is pretty obvious also, right? Because ARIMA is traditional statistics. Has its origin in decades back. XGBoost is a machine learning technique, relatively new than ARIMA. Again, around a decade back or so, XGBoost is there. Whereas long short-term memory, the deep learning techniques are pretty new, and they are much more sophisticated. So the predictive power of this model is like 93.9. I'm getting here, almost 94% is the forecasting accuracy I got through long short-term memory. So that's the kind of final model. Though that's what I was saying to you. You must apply all the applicable models, then compare across the models, and then give the best to the client. But you cannot just bank on one technique. That's very important. And so then we also here I have just given you the outline, but then we mapped this benefit, this long short-term memory forecasting benefits with how that is helping in the production. What is the kind of customer is any client is very important about the ROI chart. So say for example, the value of this project is say $2 million they are giving to me. Then client must want to see that how this $2 million spent is giving them a higher ROI, how it is coming in a 5 million at a very short span of time, in the next 6 months or the next 1 year at max, this 2 million increases to 5 million. So that kind of ROI chart one is supposed to create, like what is the kind of production, it helps in production, how does it help in marketing, how does it help in supply chain, and what kind of cost savings or the revenue generation you are doing by applying this long short-term memory forecasting technique. So that's again a very important part. As a business guy, you must translate all your models to an ROI chart. What I want to always always repeatedly say that we in the academic world, because I'm coming from academic world, so I know academic world or the research teaching very well. First 10 years, I told you in the first class, the first 10 years of my career was into this kind of schools, leading the schools of the country. So I was much, even I was much, much bogged down with the intellectual pursuit of the things, of mathematical part. Yeah, I applied 5 models. This is the accuracy. But when you enter in a business world, this ROI part is very important. So nobody will care whatever model will develop. What is the model accuracy? That's very good. But is it giving you the money? Is it giving you the desired revenue? That's the most important part. So after every work, even not only after, even before, when you're developing a proposal to get any project, I'm sure you all know, right? To get any project, you are supposed to develop a techno-commercial proposal first. You have to give a sales pitch. If the customer seems interested, customer will discuss their problem. Then you come out with a techno-commercial proposal. That yes, techno-commercial proposal means it will tell you it will tell the client rather very clearly, yeah, these are the kind of solution framework, these are algorithms, this is the entire architecture I'm going to develop to solve your problem. And this is the kind of total time, cost, this many amount of number of resources will work. So that's the total flow to accomplish the project. So that's precisely is the kind of techno-commercial proposal. And that techno-commercial proposal, when you're mentioning the budget, you have to mention it very clearly why an ROI is what kind of ROI the client should envision if the client invests in the project. So that should be a kind of dollar component, monetary component associated. So being a business guy, you can't afford to ignore that aspect. So yeah, all these techniques are very important. You should do, you must learn, you must make your hands dirty, fingers dirty to do these things. But keep your vision as a business guy also to that. What is the kind of value in terms of dollar? It can be non-monetary also, but then it should give significant amount of value to the client. No client will just spend their valuable dollars or will invest to if you just say that, yeah, I can do LSTM, I can do extreme gradient boosting. That's very nice, but then what's in it for me? Yeah, that's what they ask. I hope I'm clear, right? What I'm saying to you, making sense to you? What I'm saying? Hey, am I audible to you?
Yes, sir.
Okay. Okay. And am I making sense to you? What I've said to you, is there any question? Have you understood? It is a kind of long monologue I gave. Any question you are having? So if
No, sir, not for now.
okay, so what I can do is that I can give you that how you can take this learning forward. That's a very important part. So whatever you are learning today, how you can how when you will go back to your study time, self-study time, how you can take back the learning. So you go through what are the different techniques has been discussed within the class. Okay, so I have today Shapley value regression, ARIMA, extreme gradient boosting, LSTM has been discussed. So you go back to the different sites. You have the books. Possibly it is less that these modern techniques are explained in the book. But all that are thousands, millions of sites, they're really good. Some sites are really good from all the leading universities, leading consultancy houses across the globe. So they also discuss. So this is the way to study. So first, you try to understand the technique from a statistical point of view, mathematical point of view. What kind of formulas? What are they doing? So that part is that spend say half an hour on that, understanding the techniques from a mathematical perspective. Then you see what kind of applications they are having in the business houses, like for what kind of forecasting problems have been solved by applying extreme gradient boosting. So, for example, I was reading through a paper like this. Let me show you also. Yeah. So this paper is about an application of a three-stage extreme gradient boost based model to sales forecasting of a cross-borders e-commerce enterprise. So yeah, study by yourself. And their internet is flooded by this kind of papers. If you want, I can even share that thing. Say the way I shared yesterday. I don't know whether you have read through it or not. I shared my take on recommendation engine. I've also shared the application of that recommendation through YouTube. The same thing, extreme gradient boost. If you read first, and then you can read the applications. I shall share this paper also. I don't mind. And these are all freely available in the internet. Not that you have to purchase. Most of the things are free. That's the beauty in today's world. So look how they've applied that thing. So that will give you a kind of decent understanding. They've applied both ARIMA and extreme gradient boosting for forecasting. So study that part. That's the second stage. Third stage is the most critical. Try your hand. So, ladies and gentlemen, these classes, 1 hour classes, are never sufficient to make you a master of the subject. What my job is that I'm just your guide. I can show you, hey, you have to go to this, understand these 5 algorithms, And this is what the algorithms on a very high level, that's how things actually work. These are the applications and operations also. So I'm covering the three parts in the short 1 hour, like, what does this theory look like? ARIMA, what does AR stands for, I stands for, moving average stands for, MS stands for. And then I have also shown you in an application what I've done in a use case in the industry, and I have shown you the data file. The same thing you have to do. The same thing you have to do to master the subject. Like, what does this theory look like? Theory is saying. Then let's come back to the application in such kind of research papers, or even the white papers for the not necessarily research paper, then many white paper for the industry. Read the different applications. Just Google applications of ARIMA in sales forecasting, applications of XGBoost in sales forecasting, application of LSTM in sales forecasting, and then you will get all these kind of results. Read them, and finally open your Python book, Jupyter notebook, or SPSS, SAS, whatever suits you, Statistica, even for the sales forecasting. eViews is there. Yeah, eViews is again a leading software, mostly used by the financial folks. So study those things by yourself, and I'm sure you will face problem, and it is good to face the problem. Face the problem, try to solve by yourself, read the different forums, get yourself registered to Kaggle, different forums where these kind of problems are discussed, how to find that thing. Now, whatever the problem it is throwing, you Google that problem. That's how, we all do who's in the software industry. We Google that problem, we get multiple solutions. There are forums in which the problems are discussed, they come out with a solution. Read those things, apply that solution. That's how you can develop. That's a path to develop. That's a hard path, no doubt, but that's the only option. There is no shortcut to it. Am I clear, guys? Am I clear with what I'm saying?
Yes, sir. So can you share this SPSS data sheet so we can practice on that?
Yeah, I need not share. So you know where from I've taken it. These SPSS data sheets come from this software only. Let me tell you what you have to do it. Even I can share, but you can buy multiple such data sets. So IBM, SPSS, trial data, whatever you can say, or sample data, I can say. Sample data, broadband. You have to go to IBM Knowledge Center. That's where I have downloaded from. I don't have anything, with me. I can share it with you, but my point is I don't mind to share because these are all freely available. Not that I have personally created. These are all freely available. So you come here, you look. So many data sets are there. This is the broadband one out of the many. Let me show you. You look. Broadband underscore to broadband underscore one. This is all freely available. थोड़ा सा Google करो सब कुछ मिल जाएगा. Everything is there. Everything is there. Internet. So yeah, may not be files are available here. You could just do a little bit of more searching. That's what I did also. But I shall share this thing. Not that I shall not share. I shall share, but everything is there in the internet. That's what my point is.
Sir, but
Okay, guys. Any other question?
yes, sir. I have a question. But if we find the question like samples data in the Google, then we have to do the data cleaning also, no?
Ideally, you should do. Though you can escape, but ideally you should do. I think you start practicing that as well. Do you know how to do that thing?
No, sir. No, sir.
For this kind of SPSS files, you need not. Let me do one thing. Tomorrow I shall start my day with a little 15-20 minutes I shall spend on this how to clean the data. I shall spend some. That's a very important part. Good that you asked the question. But by the way, Kriti, if you download this data, you need not do those techniques because these are clean data meant for the students to practice.
Okay, sir.
Okay, but it's a good question. I shall take it and I shall walk you through what are different missing value imputation techniques, outlier detection techniques in the next class. I shall start with that. Tomorrow is dedicated for retail analytics, but first 15 minutes I shall deal with that part.
Okay, sir. Thank you, sir.
Welcome. Any other question you are having?
No, sir.
Okay, perfect. All the best. Do let me know if you have any doubts. Do feel free to mail me. I shall be glad to reply that and practice.